Ready? What's the problem, Philip? I started recording now. We have to learn. All right. We have to find the values of f of -6 and f of 5 for part A. Everybody get that? Yeah. So what do we have to do? We have to use this initial value that we're given of f of -2 equals 7. And let's find f of 5 first. So f of 5 ought to be the integral from -2 to 5 of f prime plus the value at -2 plus 7. Right, so take the initial value and then integrate from the x value that you were initially given to the new x value you're looking for. Everybody good with that? So the integral from -2 to 5 of f prime ought to be the area between the curve from -2 to 5. All of that blue space right there. Okay. Now the blue space is back. Isn't that great? Okay. So how do we do that? Well, 7 plus, and then what's the blue semicircle? It's below the x-axis, right? Which means it is negative. It's a semicircle, which means it is 1/2 pi times the radius squared. What's the radius?
2.
2. And then we also have to add then this blue rectangle up above. And that one should be, did I say rectangle? Triangle. That's a triangle. 3 sides, triangle. 1/2 base times height. So we end up with 7, and we end up with a plus 3 here. So that ought to be 10 minus what? 2 pi. So f of 5 is 10 minus 2 pi. Everybody feel okay about that? All right. What about f of -6? F of -6 ought to be that same 7 plus the integral from -2 to -6 of f prime. What's wrong with this integral? What makes this integral annoying? Yeah, it's the wrong way. The lower, the higher number is on the lower limit, right? And the lower number is on the upper limit. So we want to flip that and flip the sign. So we'll make this 7 minus the integral from -6 to -2 of f prime. And what is the integral from -6 to -2? Well, that's just a triangle with a height of 2 and a base of 4. So 7 minus 4, which is 3. So f of -6 is 3, and f of 5 is 10 minus 2 pi. Everybody good with part A there? You guys all good? Everyone's good? People good? All right, part B. We want to know when is f increasing? Well, when does a function increase? When f prime is?
Positive.
Positive. Oh, we look at this. When is f prime positive? Looks like, and because we're talking about increasing, we're always going to use brackets. So we're going to say it's increasing from -6 to 2, or sorry, -2, and then again from +2 to 5. Good or no? Everyone's good there? Any questions at home on part B? Everyone here is good. All right, part C. Find the absolute minimum of f on that closed interval -6 to 5. When we talk about an absolute minimum on a closed interval, we have to remember that we need to check the endpoints. Always remember to check the endpoints, and you have to check any places where f prime, if we're looking for a minimum, we want f prime to go from negative to positive, right? Because that would tell us that f is going from decreasing to increasing. Right? We don't need to worry about places where f prime goes from positive to negative, even though that's still a potential local max. Right? We just care about when it's going from negative to positive. So we will look here. Our endpoints are -6 and 5, and f prime goes from negative to positive here at 2. So we need to figure out what is f of 2. So our endpoints were -6 and 5. Our critical value where we went from negative to positive was 2. So we figure out f of 2. What is f of 2? F of 2 is 7 plus the integral from -2 to 2 of f prime. And what's the integral from -2 to 2? Well, that was that semicircle. That semicircle was a negative
2 pi.
2 pi. So f of 2 is 7 minus 2 pi. F of 5 was 10 minus 2 pi. And f of -6 was 3. Which one of those is the smallest?
F of 2.
F of 2, 7 minus 2 pi. Everybody good there? F of 2 is where the derivative goes from negative to positive. It's a place where f prime is 0. Right? F prime, this graph, is equal to 0 at 2. And it goes from negative to positive. It's also at f prime also equals 0 at -2, but we don't need to worry about that one because the derivative is going from positive to negative, which tells us that the function itself is going from increasing to decreasing. So we're not going to have a minimum. Oh, okay, part A. Mm-hmm. Well, when we talk about the area underneath the curve, we talk about it as going from left to right, right? And so we have to do left to right. So you have to flip them so that the smaller number is the lower limit and the larger number is the upper limit. If you don't flip them, that's fine. You can remember that anytime you go from right to left, that integral comes out to be negative. But I feel like that starts to confuse people. Like if they had you start over here, and then you had to go from right to left, you'd be like, all right, I'm going right to left, so it's negative, but then this thing is below the x-axis, so then it's negative again, so then you'd be actually making it positive. It just gets a little convoluted. So I think it's easier just to flip it so that you're always going left. Right, like when you're evaluating on your calculator just on some value, it doesn't matter because your calculator knows that if the lower limit is, you know, if they know that if the lower limit is larger than the upper limit, then the answer should be the opposite of whatever the regular and they're going to be. You know, they just do. That help? Yeah. Sure. Everyone good? People at home, you still good? Zoom good?
Yes, good.
Yes.
Good, Zoom. All right. F double prime of -5, F double prime of 3. So F double prime of -5, well, what does that mean? That just means the slope of F prime at -5. Well, this is our graph of F prime, so our slope of F prime at -5 is just the slope at that point. Well, that's just a linear piece, right? So what's the slope of that line?
-1/2.
-1/2. Yeah. Yeah. Yep. And then what about at F double prime of 3? The slope here at this point. Well, at that point, F prime has a
Corner, so it doesn't
corner.
exist.
So we would say the slope does not exist. You could say that it's because there's a corner there. I think that would be good with that. But if you want to be really technical, you would say something like the slope from the left as you approach 3 from the left is, what is that, 2. And the slope as you approach 3 from the right is -1. And 2 does not equal -1. The derivative from the left and the derivative from the right are not equal. Therefore, the derivative at that point can't exist. Good or no? Philip, you good with that? Oh, okay. You look like you were staring off into another world. Staring off into wherever the gophers go when they're
Wait, I have a question.
done. Oh, yeah, question?
Why does the -5 one not exist? Like, is that what it's saying in the
No,
problem?
no, the -5 one does exist. The -5 one
Oh,
is
okay.
-1/2, because that's the slope at, from both sides of -5. Oh, I didn't put that at -5, did I? Sorry, -5.
Okay. I just kind of read the problem wrong because it said explain why it doesn't exist, and I thought it meant for both.
Oh,
-5
no,
and
yeah,
3.
you're either finding the value, which for this one it does have a value, or explaining why it doesn't exist.
Okay. Thank you.
Yep. All right, everybody good? All right, let's do another one of these. That looks like a good one, huh? We have definitely not done this one. Is that accurate? All right, I'm going to give you guys 15 minutes to work through this one, and then we will talk about it. And I'm going to think about all the gophers. Ready, go. There we go. Wonderful. So we've got this lovely piecewise defined function here with a bunch of linear pieces. And we've given it g of x is the integral from 2 to x of f of t dt. We want to know if g has a min, a max, or neither at x equals 10. So first off, we have the graph of f. How are g and f related based on this statement right here? The derivative of g ought to equal f. And this is something that they really often will give you points on the AP test for just writing this relationship between the functions. So I suggest that you write that relationship whenever you have these graph problems. So g prime is f. So if we want to know when does g have a minimum or a max, or if it has one at 10, we need to look at what happens to f at 10. So our question should be, does f change signs at 10? Follow along. Oh, there's 10. Does f change signs at 10? No. No. So neither. If f went from positive to negative, it would have been a max. And if f went from negative to positive, it would have been a min. But it doesn't change signs. And that's exactly what you would write. You would write, no, it has an either at x equals 10 because there is no sign change on the derivative of g, which is f. F doesn't change. Everybody good with that? What? That's wonderful. I'm glad you have successfully completed one part of one problem. That is good. Part A is not always the easiest. In this case, it is, but not always. Okay. Part B, does the graph of g have a point of inflection at x equals 4? So if we're looking for a point of inflection, what does that tell us about g? G double prime needs to be changing signs, not just equal to 0 or undefined, right, Tom? Yeah. We got to power up and see if we're going to change signs at x equals 4 for g double prime. So we take a look at g double prime. Well, what's g double prime? It's the derivative of g prime, which is the derivative of f. So we're looking at f prime. Does f prime change signs at x equals 4? So let's find x equals 4. First off, here's x equals 4. The derivative of f. What's the derivative of f? It's the slope, right? So what's the slope as we approach 4? Positive 2, right? And what's the slope as we go away from 4 to the right? Negative 2. We went from positive 2 to negative 2. That's a sign change. Yep, that's a sign change. That's good. So we'll say yes. Justification is the slope to the left of 4 of f, or f prime, starts at 2, moves to negative 2. That happens at 4. Therefore, point of inflection. Good? Wonderful. Did you get that one right too, Tori? All right. I'll take what I can get. You're still powering up. You'll get there eventually. All right. Part C. You okay, Tom? Yeah. All right. What is your new name? Brigade Commander Tom. He's in the process of powering up to become Brigade Commander Tom. I understand. Right now, he's just Tom. But soon, he'll power up to Brigade Commander Tom. The most enthusiastic you've ever seen me? That's not true. Hey, you can't tell him what his reality is, okay? You don't know what he's seen. All right, part C. Find the absolute min and the absolute max. Okay, so to find the absolute min and the absolute max, number one, we have to check the endpoints. And number two, we have to check any time where the derivative crosses through the x-axis. So if we're talking about the absolute max and min of g, we're talking about when does f cross through the x-axis. That'd be at -2. That'd be at 6. Those are the only places where it crosses through the x-axis. Everybody agree with that? Okay. So we need to check the value at -2, the value at 6, the value at -4, and the value at 12. So we will be looking for g of -4, g of -2, g of, what was it, 6, 2? Oh, 6, it was 6, okay. 6, and then the last input was 12. Is that right? Okay. So how are we going to find all those values? So we know that g is the integral from 2 to x of any of those. So let's start with the easy ones that move to the right. And let's also, I think this might just make our lives easier. Let's look at all the different regions. What's this one's value here? This area here.
-4.
-4, right? So it's positive 4 is the area, but the integral part of it is -4. I'm gonna put a -4. That's right. This one is 8. Is that right? This one is also 8. This one is a -8, and then this one is another -4. And that's going to make our life easier as we try to evaluate these integrals. So at 6, what's the integral from 2 to 6? 8.
8.
So g of 6 is 8. What about from 2 to 12? To find the value at 12. Well, that's 8 minus 8, and then -4. So what's that one's going to be?
-4.
Great. Then if you want -2, well, to get -2, that's going to be an integral from 2 to -2, right? Of f. What do we need to do with that? Flip it. So we're looking at an opposite of an integral from -2 to 2. So the integral from -2 to 2 is 8, and the opposite of that is -8. And then if we want -4, we'll do the same thing. We'll just take the opposite of the integral from -4 to 2. So the integral from -4 to 2 is -4 plus 8, which is 4. And we'll take the opposite of that, which is -4. You okay back there, Patrick? Everything all right? All right, we need to finish this problem. You said you were going to tell me later, and then now you've gone and distracted the whole class. This is awful. You are not powering up right now. Good. All right, everybody good with that? So then we want to know what is the absolute min and the absolute max. Well, the absolute max is 8, and it occurs at g of 6, or it occurs at x equals 6. And the absolute min is -8, and it occurs at -2. Everybody good with that? Soon, Patrick. Soon we'll be doing another problem, and then you can show me what horrible things you have to show me. Yeah. But as for the max, you are what? Yeah, you give the actual value, not where it is. Yeah. Sometimes they will ask where does it occur, and then you got to give that. So just be careful with what it says. So in this particular one, it says find the absolute min and the absolute max. Give the y value. If it says find where they occur, give the x. Everybody good with that? Yeah, I mean, you'd show the values of each of these, and then you'd have to show some. I mean, we put all this stuff on here to show what each of those was the value of, and then this to show like how we got the more difficult ones would be fine. Yep. All right, last one here, part D. For -4 to 12, find all intervals for which g of x is less than or equal to 0. Well, where does g of x equal 0 for sure? Remember that g of x is the integral from 2 to x of f of t dt. So, yeah, at x equals 2, we know it equals 0, right? True? Everybody agree with that? Okay. So we should then from there be able to figure out when it's positive and when it's negative. We want to know when it is negative. So if it's 0 here, now I've added in an area of 8 for the value of g, going from 2 to 6. Definitely not negative, right? This is all positive from 2 to 6. As I go from 6 to 10, like starting at 2, right? I went from 2 to 6, I'm at a positive 8, and then I'm continuing to 10. All of these values between 6 and 10 over here are still positive, aren't they? Right, because I'm putting in negative pieces to it, but it takes the full space between 6 and 10 to get back down to equaling 0 again, right? G equals 0 here, then it equals 8 here. By the time we get here, it's back to 0. But it was still positive. G was still positive all the way from 6 to 10. You all agree with that? Then from 10 to 12, now g equals -4, and that whole time it was getting negative. So we know that it's negative from 10 to 12. And then what about on this side? We know that it was 0 here. We could start at -4. What was it at -4? G equals -4. It's -4, right?
4.
So this value at -4 is negative. It's negative until we get here to -2, right? This is still, what is this? It's still -8, isn't it? At -2. And then it takes all of these 8 positive units to get back to 0. So it should be negative from -4 to 2 also. Does that make sense to everybody? What? It's negative from -4 to 2. Right, because at this value, we were already at -4. At this value, g was equal to -8. That was our absolute minimum, right? And then it's adding in 8 units between here and here, but during that whole period between -2 and 2, it's still negative because, you know, I've added in 1 unit. I'm at -7, then -6, -5. Now I'm at -4 here. Then make sense? Everybody good with that? Question? Why am I? It's just asking when is the function less than 0? But less than or equal to 0? Shoot. Sorry, less than or equal to 0. I should probably read the problem. Good question. I'm using parentheses because I didn't read. I need to power up. Everybody good? Okay. Why is g equal to -8 at -2? Well, because that's, where did I put it? G. Right. Does that make sense? Wonderful. Good job, Brigade Commander Tom. Brigade Commander Tom explained to Emily the question. All right, everyone good? Anybody in Zoom have a question? Zoom questions? Zoom questions? All right, do this one. This time I'm going to actually set a timer. Ready, go.